Hello, AP Environmental Science students. In today's screencast, we are going to go over Chapter 7, which is about climate and terrestrial biodiversity. All of today's notes are based off of Living in the Environment, the 16th edition by Miller and Spoolman. So, Chapter 7, Section 2 covers how does climate affect the nature and locations of biomes. So again, the big idea here is going to be biomes. Differences in average annual precipitation and temperature lead to the formation of tropical, temperate, and cold deserts, grasslands, forests, and largely determine their locations. So first, climate affects where organisms can live. Scientists have divided the world into several major biomes, and biomes are just large terrestrial regions that are characterized by similar climate, soil, plants and animals, regardless of where they're found in the world. So we could have a tropical desert in Africa and in South America. Biomes don't really have sharp boundaries. It's not like this section is only desert or this section is only temperate rainforest. It's actually a mosaic of patches. So within biomes, we have different sections that can have their own little microclimates or their own biome. Climate and vegetation vary with latitude, elevation, temperature, and precipitation. So over here, it shows this nice little figure that as we get higher in elevation, we go from tropical forest all the way up to mountain ice and snow. And this also shows latitude. So the closer we are to the equator, the more tropical our forests are, and the closer we get to the poles, we get that ice and snow. The second figure here shows precipitation. So where it's really wet and hot, we have rainforest. As precipitation decreases and temperature decreases, we get a variety of different biomes. So there's three major types of deserts. A desert is just a biome that has low annual precipitation that is scattered unevenly throughout the year. So our first type of desert is a tropical desert. This is like the Sahara Desert. This is what you imagine when you see deserts in videos. Big, sprawling sand dunes, no vegetation, hot and dry. So it's hot and dry most of the year. Like I said, very few plants, hard wind-blown surfaces of rock and sand. And windstorms can be a big problem. And actually, there's something called the SUV connection, where we have these increasing numbers of four-wheelers that speed over the sand, break up the surface, and then wind comes through and blows the dust into the atmosphere. So the windstorms are actually getting a little more dangerous and a little worse because it's kicking up all of the sand that these four-wheelers have released. We also have temperate deserts. So this is kind of what we see in the New Mexico, southwestern United States. We have high daytime temperatures in the summer, low in the winter. There's more precipitation here than in tropical deserts, and this is what you think of when you see these big cacti, drought-resistant shrubs, and other succulents. The third type of desert is the cold desert, and this is like the Gobi Desert. Winters are cold, summers are warm or hot. There's still very low precipitation, sparse vegetation. Desert plants and animals have adaptations to help them stay cool during those summer months and get enough water to survive. Then we have grasslands, and grasslands is kind of your intermediary between a desert and a forest. So there's enough annual precipitation to support growth of grass and small plants, but not enough to support a lot of large trees. First, we have tropical grasslands, which is also the savanna. It's warm year-round. We have alternating wet and dry seasons. There's scattered clumps of trees and then low-lying shrubs. And then there's two major types of animals that live in the savanna. We have grazing animals, which eat grass and herbs, and we have browsing animals, which eat twig and leaf. And examples of grazing animals would be things like zebras, twig and leaf, or browsing animals would be like giraffes. Our second type of grassland we are all very familiar with. It's the Midwestern Prairie. Here we have very cold winters, very hot summers. Annual precipitation is sparse and falls unevenly. We have deep, fertile soil, And our plants are adapted to fires. They've got very deep roots, so if the fire goes through the prairie, only the tops of the plants burn and the roots can come back and grow more plants. We have two distinct types of prairies. We have tallgrass prairies, which have longer roots and generally receive more rain, and shortgrass prairies, which have shorter roots and less rain. Then we have cold grasslands, or the Arctic tundra. Here it's bitterly cold, windy, and covered with snow and ice for a majority of the year. Winters are long and dark, and most of the precipitation there falls as snow. It's dominated by grasses, mosses, lichens, dwarf shrubs, because its soil is mostly permafrost, which is underground soil in which captured water stays frozen for at least 2 years, most likely more. Here, animal adaptations help them stay warm, so thick fur or living underground during these really cold periods. Cold grasslands are fragile. It's a very fragile biome because their soil is nutrient poor. It recovers very slowly from damage because it's very short growing season. Most of the time it's too cold for things to actually grow. So it's hard if damage comes through for things to recover. Also, there's a lot of human activities going on in the cold grasslands and disturbances such as drilling, pipelines, mines, and actually a lot of military bases. We also have something called the alpine tundra, which is between tree growth and below permanent snow on high mountains. The only difference between our regular grassland tundra or cold grassland and our alpine tundra is that the alpine tundra generally receives a little more sunlight because it's higher up in elevation. So there is a little bit more growth in the alpine tundra than there is in our normal Arctic tundra. Kind of an in-between our grasslands and our forests, which we'll talk about next, is this temperate shrubland or chaparral. This is a biome that's found in coastal regions that border on deserts. Our example here in the United States is the coastlines of California. They have slightly longer winters than nearby deserts. They have a lot of fogs coming off the ocean in the spring and the fall. There's dense growths of growing evergreens, thin and infertile soil, and they have long, warm, and dry summers. During these dry summers, vegetation becomes really dry and is susceptible to fires. So a lot of these plants have fire-resistant roots, food storage areas, deep roots, and only produce seeds after a fire. So a lot of fire adaptations. People like to live here because of its moderate climate, mild winters, and sunny dry summers, but they have to worry about fires taking their homes and their belongings because, as I said above, these long dry summers often lead to dry vegetation that can easily catch on fire. So there are also 3 major types of forests. First, we have tropical rainforests. Like the Amazon rainforest, they are found near the equator. Their uniformly hot temperatures have high humidity and heavy rainfall almost daily. They're dominated by broadleaf evergreen plants. So these are like your typical leafy trees, but because it's warm all year, they never lose their leaves. And they form this very dense canopy. Because of this canopy, there's very little ground level vegetation because not enough sunlight gets through that canopy. We have lianas, or vines, that grow from one tree to another that provide pathways for many species to walk through the rainforest. And because of the high amount of vegetation and greenery, we have a high net primary productivity. Remember, net primary productivity is the amount of energy that's left over after our plants do photosynthesis. Tropical rainforests are super important because they contain at least half of the Earth's terrestrial plant and animal species. Within our tropical rainforest, we get most of our ingredients or blueprints for our prescription drugs. So if the rainforest goes extinct, a lot of our modern medicines will as well. Life forms occupy a variety of specialized niches and distinct layers. So think like canopy, the ground level, in between. All of these different layers of our tropical rainforest enable all of these species to coexist with each other. Because of all the tree life, there's very little wind that actually blows through the rainforest to disperse seeds. So most of our plant species rely on bats, butterflies, birds, bees, and other things similar to pollinate or spread seeds in their droppings. Because of the warm and extremely humid temperatures, there's fast decomposition and fast recycling of nutrients. Because most of the nutrients are pulled up into the trees and other vegetation, our soils are pretty nutrient poor because of all of the constant rainfall and all of the actual vegetation. This means that it's not good for growing crops or grazing cattle, but despite this limitation, we're still knocking down trees and using the land for just that. At least half of these forests have already been destroyed or disturbed by human activities, and if we continue on the same path, they're going to be gone very soon. Another forest is our temperate deciduous forest. This is mostly in the eastern United States, although we do have some in the state of Illinois. We have moderate average temperatures, which change significantly with the seasons, so very cold in the winter, very hot in the summer. A lot of precipitation that falls uniformly throughout the year. These are our broadleaf deciduous trees, and deciduous just means that they drop their leaves and become dormant in the winter. They change color in the fall. There's very slow decomposition, which means we have very nutrient-rich soil, and this is disturbed by human activity more than any other biome, and it's cleared for crops or homes. Then we have our evergreen forests. These can also be called the taiga or the boreal forests. It's found just south of the Arctic tundra, and here we have subarctic climates with long, dry, and extremely cold winters. In the winters, we only have 6 to 8 hours of sunlight, while in the summers that are short and cool, we have about 19 hours of daylight. Here we have coniferous evergreen trees. So this is like your typical pine tree with the waxy coated needles. These needles can withstand intense cold and drought, so they last very well, or they thrive very well in this environment. There's very low biodiversity because it's only a very specific type of species that can survive, and their soil has is acidic and nutrient poor because of slow decomposition. There's also coastal coniferous forests or temperate rainforests. The only difference here is that, again, we've got a lot of rainfall, but there's a lot of ocean fog as well. Finally, we have mountains. And you guys all know what mountains are. They're steep or high lands that cover almost a fourth of the Earth's surface. Here, when vegetation is removed, soils are easily eroded. So when disturbances come through like an avalanche or glacial movement, it often takes a little while for our ecosystems to recover. The majority of the world's forests are found on mountains, and it's a habitat for much of Earth's biodiversity. It also is habitats for endemic species, and remember, endemic species are just those species that live in a very specific spot. Mountains help regulate the Earth's climate by absorbing heat from the sun, melting snow, or keeping or reflecting the sunlight back from the snow at the top of the mountains. They can affect sea levels by storing and releasing water in their glacial ice. And they're a major storehouse of water and play a major role in the hydrologic or water cycle.